Hi there, and welcome back to the channel. I'm the GCSE science teacher, and in today's lesson, we will be discovering all things to do with the atomic model and how it has changed throughout time. This is a really important topic, not only just in chemistry, but you also find it in the GCSE physics curriculum too. So let's get started. So, if we go back in time to 465 BC, we'll find a Greek philosopher called Democritus who came up with the idea of atomus. This idea that everything around us is made up of atoms or very tiny structures. Now, he wasn't entirely sure what these structures looked like, but he believed that atoms all had different sizes and shapes, which we actually know is not actually quite accurate. And we're going to discover what other scientists throughout history thought too. This is pretty common in science, actually. New experimental evidence may lead to different scientific models being changed or even replaced over time. And this is a good thing because it means that we're constantly challenging our own ideas and the ideas of others and using evidence based research to improve upon them. So let's have a look at how the atom has changed over time. So in 1803, there was a scientist called Dalton who came up with the idea that the atom was made of tiny spheres which were solid and could not be divided. This was really important because he came up with this idea before the discovery of the electron. And that changed quite rapidly when the electrons were discovered. And in 1903, J.J. Thomson used that idea to come up with the plum pudding model of the atom. Now, for GCSE, you will be expected to know what the plum pudding model is, and you could be expected to compare it to other models of the atom too. So, the plum pudding model was actually an idea that the atom itself was made up of mainly a positive charge, which he called the pudding. He also said that the atom itself had negative sections where the electrons were embedded within the positive pudding. And those electrons were the plums in this model. Later on in time, in 1911, Rutherford did various experiments using alpha particles. And what he did was he fired alpha particles at the atom of gold, or Au. And this is often referred to as the alpha particle scattering experiment. The conclusion of this experiment showed that the mass of the atom was concentrated in the center of the nucleus. And he found that out because although a lot of alpha particles passed through the atom itself, some were rebounded. And that meant that when the alpha particle hit the nucleus, they actually were essentially pushed away and rebounded against them. And this essentially meant that the results from the scattering experiment led to the conclusion that the mass of the atom was concentrated in the center, or what is now known as the nucleus, and that the nucleus must be charged as well. This nuclear model replaced the pudding model, and then further evidence was used to add to this model moving forward. So in 1913, Bohr added to Rutherford's experimental methods, and he adapted the nuclear model by suggesting that electrons were able to orbit the nucleus at very specific distances. In 1926, Schrödinger came up with an idea of the atom being a quantum model. And essentially, he suggested that the positions of those electrons were now going to be described in probabilities. So we weren't entirely sure where those electrons were, but we could give a roundabout estimation. And this was backed up by experimental and theoretical research, and it continues to be used in the scientific field. Later on in 1932, Chadwick came up with the idea of the model that we see more often now in textbooks and what we kind of see as the typical atomic model. And this was 20 years after the nucleus became an accepted idea. Essentially, Chadwick was responsible for neutron discovery. So the neutrons we know are found within the nucleus along with protons, and the electrons orbit them. So this is kind of a huge difference to what it started off like. I hope that was helpful. If it was, please feel free to comment, like, and subscribe, and click the bell notification for future videos that I do. In the meantime, you can also check out my Instagram for further GCSE science content. Thank you so much for watching. I've been the GCSE science teacher, and you have been curious. I will see you in the next one. Bye.